Step into any modern car, and it's just, well, it's mind-blowing, isn't it?
Absolutely.
You got thousands and thousands of parts, right? All engineered to incredible precision, coming from suppliers literally all over the world.
Mm-hmm.
That tiny little bolt from supplier A has to mesh perfectly with some complex electronic module from supplier B.
Right. And the tolerances are tiny.
Exactly. And the dashboard plastic from supplier C needs to meet these, exact safety and aesthetic standards. And it all has to happen consistently, reliably, car after car, year after year.
It really does feel like a high wire act, sort of this incredible feat of coordination and, crucially, quality control. How do you even ensure that level of consistency across such a complicated global network?
Yeah, how do you do that? And that's the system we're pulling back the curtain on today. Welcome back to the Deep Dive.
Good to be here.
Our subject is IATF 16949. Now, if you work anywhere, and I mean anywhere, in the automotive supply chain, maybe you make a component, an assembly, maybe even the raw material that goes into a part. This isn't just some, abstract standard collecting dust on a shelf.
No, far from it.
It's basically the global operating system for quality in this industry. It's your ticket to play.
And that's really our mission for this deep dive, isn't it? We've taken this comprehensive guide you've shared, and it is packed with details covering the standard, its requirements, the essential tools, implementation, even looking towards the future. And our goal is to sort of cut through that complexity.
Right.
We want to help you, the listener, quickly understand what IATF 16949 actually is, why it's absolutely essential, and how it really works on the ground.
Think of it as your shortcut, maybe, to getting truly well-informed on the quality backbone of the entire automotive world.
Yeah, a guided tour through the essentials.
So I'll be your guide, asking the questions, maybe poking around the edges with curiosity. And my expert colleague here will provide the sharp insights, the analysis drawn directly from the detailed source material you've provided us.
That's key. This isn't about our opinions or bringing in outside stuff.
Nope.
We're sticking strictly to the content of this professional guide, which is really designed to support people who are navigating the standard every day.
Okay, excellent. All right, let's buckle up then and get into it. First things first, the absolute foundational question. What exactly is IATF 16949, and why has it become, the absolute gold standard in automotive quality?
Okay, so at its heart, IATF 16949 is the international standard for automotive quality management systems. But, and this is important, you can't really understand it without knowing it builds directly on ISO 901.2015.
Okay, so ISO 901 is the base layer.
Exactly. Think of ISO 9001 as the solid, robust foundation for a general quality management system applicable to almost any industry. IATF 16949 takes all of those requirements, every single one, and then adds a significant layer of specific, often much more stringent, demands that are tailored only to the unique needs and, frankly, the complexities of the automotive industry.
So it's not starting from scratch. It's refining and specializing an existing quality framework. Makes sense.
Precisely. It was developed by the International Automotive Task Force, that's the IATF, and published back in 2016. It officially replaced its predecessor, which was called ISOTS 26949.
Okay.
And the core driver behind it, the main motivation, was harmonization. You see, before this, you had different major automakers or regions like the US, Germany, Italy, each with their own quality standards.
Oh, I can imagine that was messy.
It created incredible inefficiency, duplication, and confusion in the global supply chain.
Yes.
So the IATF's objective was, and it still is, to create a single, unified quality management system standard for the entire global automotive sector. The aim: ensure consistency, drastically reduce that variability from one supplier to the next, and really drive efficiency throughout this incredibly complex network.
Where did this push for a single standard even originate? Was it just, like you said, too much of a mess before?
Oh, absolutely. If you look back, you had these distinct regional standards. There was QS 9000, primarily driven by the U.S. automakers. You had the VDA standards in Germany, AVSQ in Italy.
Right. Different rule books everywhere.
Exactly. And as vehicle production and supply chains became increasingly globalized, parts made in one country, assembled in another, sold in a third, trying to manage multiple overlapping or sometimes slightly contradictory, quality systems became a huge burden for suppliers.
Yeah, I bet.
So the move first to ISOTS 16949 and then the refinement to IATF 16949 really reflects this global reality. It's an evolution driven purely by the industry's need for a shared, rigorous approach to quality no matter where you are in the world.
Okay, that makes sense. So who exactly falls under the umbrella of IATF 16949? Is it just the big car companies, the Fords and Toyotas and BMWs of the world?
No, and this is one of the most crucial points to grasp. While the major vehicle manufacturers, the OEMs, are definitely the driving force and they often mandate it, the standard applies to any organization that produces components, subassemblies, materials, or parts that actually go into automotive production.
Any organization. So that means it cascades down.
Precisely. It cascades down the supply chain. It applies to the Tier 1 suppliers selling directly to the OEMs, sure, but it also applies to the Tier 2 suppliers selling to the Tier 1s, the Tier 3s selling to the Tier 2s, and potentially many, many levels deeper down the chain, provided they are producing production parts or materials that end up in a vehicle.
Wow.
And it covers the entire product life cycle, really, from the initial design and development phase right through manufacturing, installation, and even the production of service parts later on.
So if you make the seat frames or the engine gaskets or the little electronic control units or even the specialized fasteners that hold everything together, you're likely in scope.
Very likely, yes.
So why is getting certified to this standard so essential for all these suppliers then? Is it just, a formality, a box to tick?
Oh, far from it. For most organizations operating in the automotive sector today, IATF 16949 certification is pretty much a non-negotiable business requirement.
Really? Non-negotiable?
In most cases, yes. It's typically a mandatory contractual clause from their customers, whether that customer is an OEM directly or maybe a higher tier supplier. Without being certified, you simply cannot win or even maintain business with many of the major players. It's a gatekeeper.
Okay, so it opens doors.
It does, but beyond just being a gatekeeper, it's also a significant competitive advantage. Achieving certification signals to potential customers and existing ones that you have a mature, robust quality management system that's capable of meeting the industry's really rigorous demands.
It says we know what we're doing.
Exactly. It demonstrates commitment, capability, reliability. In today's market, it truly is the cost of admission to play in the global automotive supply chain arena.
Got it. So it's the refined global standard, born from those earlier regional needs, and absolutely essential for pretty much anyone supplying into automotive manufacturing.
Yeah.
So how is this standard actually structured? How's it organized? And what are its core philosophies, its guiding principles?
Okay. One of the key strengths of IATF 16949's structure, especially for companies that might be managing multiple management system standards, is that it follows the high-level structure, or HLS.
HLS.
Yes, high-level structure. This is the common framework that ISO adopted for all their management system standards back around 2015. So standards like ISO 9001 for quality, ISO 14001 for environmental, ISO 4501 for health and safety. They all share this common structure, common clause titles, common core text, and common definitions.
So if you're already certified to, say, ISO 14001, the layout of IATF 16949 will look familiar. Makes it easier to layer in the automotive specifics.
Exactly that. It uses the same 10-clause structure. It speaks a common language, structurally speaking, which makes building a single integrated management system covering quality, environmental, safety, etc., much more feasible and efficient. You're not managing completely separate systems.
That's smart. Reduces complexity.
It does. And the philosophy underpinning it all is built on several really core principles. Probably the most fundamental is the process approach. This is absolutely key.
The process approach. What does that mean in practice?
It means you stop thinking about managing individual departments or functions in isolation. The engineering silo, the production silo, the quality silo. Instead, you identify, understand, and manage your organization's activities as a series of interconnected processes.
Okay.
You map out what goes into a process, inputs, what comes out, outputs, who's responsible, what resources are needed, people, machines, information, how you control it, and critically, how that process links to and interacts with the next process in the chain.
So it's like seeing the whole factory, or the whole office even, as a connected flow of activities, not just separate boxes on an org chart.
Precisely. And applying this process approach systemically ensures that quality requirements aren't just, understood in the quality department. They get integrated and consistently applied across design, manufacturing, purchasing, sales, really, every part of the business. And it even extends to how you manage processes you might outsource to suppliers.
Right, and that leads to the other key principles.
Yes, it flows naturally. So you have this strong orientation towards managing through processes. Then there's a major emphasis on defect prevention. This is a huge shift for some organizations.
Prevention over detection.
Exactly. The focus is on designing processes and controls that stop problems from happening in the first place, rather than just relying on inspection to catch defects at the end of the line. It's proactive, not reactive.
That shift in mindset alone must have a massive impact.
It really does. Then there's minimizing variation and waste. This aligns perfectly with lean manufacturing principles. Things like reducing scrap, rework, unnecessary movement, waiting times. It's about efficiency driven by quality.
Makes sense. Less waste usually means better quality anyway.
Often, yes. And perhaps most importantly, fostering a culture of continuous improvement. The standard requires that you're always looking for ways to make your processes and products better, more efficient, more reliable. It's not a set it and forget it system.
Always improving. So who's ultimately responsible for making this entire system work? Does it all fall on the quality manager?
While dedicated quality professionals are absolutely vital, IATF 16949 places the ultimate responsibility squarely on top management. Their role is critical, and the standard is very clear. This responsibility cannot be delegated away.
Okay, so the buck stops at the top. What does that mean in practice?
It means leaders must demonstrate visible and concrete commitment. This isn't just about signing off on a quality policy statement once a year. It involves actively communicating the importance of the quality system throughout the organization, setting clear, measurable quality objectives that are aligned with that policy, actively participating in management reviews where the system's performance is discussed, and crucially, ensuring the necessary resources, funding, people, training, equipment are actually provided.
So they have to walk the walk, not just talk the talk.
Exactly. The standard even requires organizations to provide objective evidence of this top management commitment during audits. Auditors will look for proof.
Interesting. You also mentioned customer focus earlier. How does the standard really emphasize that? It seems pretty central to business anyway.
It is, but IATF 16949 makes it extremely explicit and demanding. Customer focus is absolutely paramount. The standard requires organizations to have robust, systematic processes for determining, understanding, and consistently meeting all customer requirements.
All requirements. That sounds broad.
It is. It goes beyond just the explicit technical specifications written down in a contract or a drawing. It includes unspoken expectations, all applicable legal and regulatory requirements related to the product, and especially, and this is a big one in automotive, of those unique customer-specific requirements, or CSRs, that each individual car maker layers on top of the standard.
Oh, yes, the CSRs. We'll need to dig into those later.
We will. But the core principle is ensuring all these requirements, explicit, implicit, legal, CSRs are captured, understood internally, translated into internal requirements and controls, and consistently met. It's about total customer satisfaction.
Okay. Is there anything else in IATF 16949 that feels particularly maybe modern or addresses current broader industry concerns beyond pure product quality?
Yes, one notable inclusion that definitely reflects broader global concerns is the requirement related to corporate social responsibility.
Oh, really? How does that fit into a quality standard?
The standard actually mandates that organizations define and implement policies covering things like anti-corruption, establishing a code of conduct for all employees, and having an ethical escalation policy, which is essentially a mechanism for whistleblowing, allowing employees to report concerns without fear of reprisal.
That's quite progressive for a quality standard.
It is. It acknowledges that being a quality supplier in the automotive world today involves more than just product performance. It encompasses ethical conduct, sustainability considerations, and responsible business practices throughout the value chain. It reflects the growing focus on these areas from consumers, regulators, and the OEMs themselves.
That's interesting. It's expanding the definition of quality in a way. What about dealing with the unexpected? Things go wrong. Supply chain disruptions, equipment failures, the real-world problems businesses face.
That's addressed through rigorous contingency planning. This is a specific requirement. Organizations must identify potential risks that could disrupt their ability to supply conforming product to the customer, and then define and implement plans to mitigate those risks.
What kinds of risks are we talking about?
We're talking about scenarios like interruptions from key raw material suppliers, unexpected labor shortages like a strike or illness, major breakdowns of critical production equipment, utility outages, power, water, IT, even things like pandemics or natural disasters.
Okay, the big stuff that can stop you in your tracks.
Exactly. And these plans can't just sit on a shelf. They must be tested periodically, You have to simulate the disruption and see if the plan actually works, and they need to be reviewed and updated regularly to ensure they remain effective. The ultimate goal is guaranteeing continuity of supply, which is absolutely vital in the often just-in-time world of automotive manufacturing. A line stoppage at the customer is a cardinal sin.
So, plan for the worst, test the plan, keep it current. That makes a lot of sense for such a lean, tightly interconnected system.
Okay, so we have the structure, the HLS, and the core principles. Process approach, prevention, continuous improvement, leadership, customer focus, even social responsibility and contingency planning. Now, let's get into the nuts and bolts of actually building this quality management system. What are the general requirements you need to put in place?
Okay, building the system really starts with establishing the right documentation. IATF 16949 requires a structured system of documented information. This typically includes things like a quality manual, which outlines the scope of your system and how it addresses the standards clauses.
A high-level overview.
Right. Then you need documented procedures that explain how key processes are carried out, who does what, when, how. Below that, you might have detailed work instructions for specific tasks, particularly on the shop floor, giving step-by-step guidance. And critically, you need to maintain records proof that processes were followed and that requirements were met. Records provide the objective evidence. So manual, procedures, instructions, records. That sounds like a lot of paper, potentially.
It can be, which is why document control is so crucial. The standard mandates a robust document control system. This ensures that only the latest approved versions of all relevant documents are available where they're needed, and that obsolete documents are removed or clearly identified to prevent accidental use.
Avoiding confusion from using old versions. Simple concept, but absolutely vital in practice.
Absolutely vital. Imagine using an old drawing or an outdated work instruction for a critical process. The consequences could be severe.
Okay, documents controlled. What's next?
Building on that process approach we talked about, you must perform process mapping.
Yeah.
This means you need to formally identify, map out, and clearly describe all your key organizational processes.
All of them.
All the ones that can affect product quality or customer satisfaction. This includes core manufacturing processes, support processes like purchasing or maintenance, and even processes you might outsource but still rely on for your final product. For each key process, you need to detail its inputs, its outputs, the controls you apply to ensure it functions correctly, the resources it requires, how you measure its performance, and how it interacts with other processes in your system. Mapping provides that visual blueprint of how your quality system actually works.
Okay, so you've mapped all your processes. How do you know if they're actually performing the way they should? If they're effective?
That's where monitoring and measurement come in. You need to establish clear methods and indicators, often key performance indicators, or KPIs, to monitor and measure the performance of your critical processes against their objectives.
KPIs make sense. Things like defect rates, on-time delivery.
Exactly. Things relevant to that specific process. This involves collecting data on key characteristics and then, importantly, using statistical analysis and potentially more advanced problem-solving techniques to understand trends, variability, and identify potential issues before they lead to non-conforming products or missed targets.
Data-driven decision-making.
That's the goal. And related to that, you need specific goals to aim for. You must establish measurable quality objectives at relevant functions and levels throughout the organization.
Measurable objectives.
Right.
Like reduce scrap by 10% this year.
Precisely. They need to be specific, measurable, achievable, relevant, and time-bound SMART objectives, essentially. These objectives must be aligned with the overall quality policy set by top management, and they should be focused on driving tangible improvement in performance. They also need to be periodically reviewed and updated to ensure they remain relevant and challenging.
Okay. Now, the automotive world is constantly changing, right? New models, new technologies, new materials, customer requests changing. How does the standard handle all this inevitable change?
Oh, change control. This is absolutely critical in automotive and a key requirement in IATF 16949. Any change, whether it's a change to a production process, the materials being used, the equipment, the software, the measurement method, anything that could potentially affect the product must follow a formal documented process.
Formal process. What does that involve?
It must include a thorough risk assessment to understand the potential impact of the proposed change. What could go wrong? What are the consequences? Then, based on that risk assessment, you need to perform appropriate verification and validation activities.
Verification and validation.
Yeah.
Confirm it works.
Yes. Verification checks if the change meets the specified requirements. Validation checks if the change achieves its intended purpose in the actual application without causing any unintended negative consequences. And crucially, this verification and validation must happen before the change is fully implemented in routine production.
Why is this level of rigor so incredibly important in the automotive sector specifically?
Because uncontrolled changes can have devastating consequences, particularly for product safety and compliance with stringent regulations. Think about it. A seemingly minor alteration to a material composition or a welding parameter, if not properly evaluated, could potentially compromise the strength of a critical structural component or affect how an airbag deploys or impact emissions performance. Formal change control, with that mandatory risk assessment and validation step, is paramount to preventing potentially dangerous or non-compliant outcomes.
That really underscores the direct link between quality management and vehicle safety. Okay, setting up the system structure, mapping processes, controlling changes, it all seems pretty demanding. What about the resources you need to actually make it all run effectively? The people, the machines, the knowledge base.
Resource management is indeed a substantial part of the standard. It covers several key areas. It really starts with human resources. You need a structured approach here. Meaning, you need to identify the specific competencies required for personnel performing different roles that affect quality. Then, you need to ensure you provide ongoing training to develop and maintain those competencies. And it's not enough just to train. You need to evaluate how effective that training actually was. Did it stick? Did performance improve?
Okay, checking the training worked.
Yes. And a key emphasis here is on awareness. The standard requires ensuring every employee understands the relevance and importance of their own activities and how they contribute to achieving the overall quality objectives. They need to understand the consequences of not conforming to requirements. There are also specific requirements for ensuring adequate quality training for new hires and making sure everyone stays current with changes.
So it's not just about having skilled people, but people who understand the why behind what they're doing. What about the physical plant, the buildings, the equipment?
That's covered under infrastructure. You need to determine, provide, and then maintain all the infrastructure necessary to achieve conformity to product requirements. This includes buildings, the layout of your workspace, production equipment, hardware and software, and supporting services like transport or communication.
Maintaining the infrastructure, like preventive maintenance.
Exactly. There's particular attention given to plant planning to ensure optimal material flow and layouts that support lean manufacturing principles. And yes, a documented preventive maintenance system for key production equipment is explicitly mandated to ensure its reliability and minimize unexpected breakdowns that could disrupt production or affect quality.
Right. Keeping the machines healthy is fundamental to keeping production flowing smoothly and consistently. What about the actual environment people are working in day to day?
The requirements for the work environment go beyond just basic health and safety aspects like temperature and lighting, although those are included. It also encompasses aspects like cleanliness, orderliness, and discipline on the shop floor.
Cleanliness and order.
Yes. The standard explicitly promotes the use of methodologies like the 5S methodology, sort, set in order, shine, standardize, sustain. It's about creating a disciplined, visually managed workspace that actively supports efficiency and quality output. A cluttered, disorganized workspace is often a breeding ground for errors.
5S, yeah, that makes sense. An organized workplace seems like it would naturally contribute to better quality control. What about the specific tools and equipment used directly in production? Molds, dies, jigs, fixtures?
Those fall under production resources. You need defined processes for planning, acquiring, and properly maintaining all the equipment and tooling used in production. This includes having systems for managing customer-owned tooling if applicable, ensuring it's properly identified, maintained, and stored. It also involves procedures for assessing your production capacity to ensure you can reliably meet forecasted customer demand volumes.
Okay, and what about the know-how? The knowledge needed to actually do the job right, especially with complex processes or technology.
That's recognized as a critical resource under organizational knowledge. The standard requires you to determine, maintain, and make available the knowledge necessary for the operation of your processes and to achieve conformity of products and services.
How do you maintain knowledge?
It involves things like capturing technical know-how from experienced personnel, documenting lessons learned from past issues or successful projects, maintaining databases of best practices, and having systems to prevent the loss of critical knowledge when people leave or retire. The goal is to treat knowledge as a valuable organizational asset.
That's smart. Prevents reinventing the wheel or losing critical expertise. Now, you obviously can't make cars or car parts without suppliers. How are suppliers managed as a resource under IATF 16949?
Supplier integration and management are absolutely crucial, as you might expect. IATF 16949 requires a very structured process for the selection, evaluation, and continuous monitoring of the performance of your external suppliers.
Monitoring, like
What?
tracking their quality scores.
Yes, that's part of it. Tracking metrics like incoming quality defect rates, delivery performance, responsiveness. But it goes beyond just checking incoming product at your door. The standard encourages a partnership approach. This often involves implementing supplier development programs aimed at actively helping your key suppliers improve their own quality systems and manufacturing capabilities.
So helping your suppliers get better.
Exactly. It could involve providing training, offering technical support, sharing best practices, or collaborating on joint improvement initiatives. The underlying principle is that the strength of your own quality management system is ultimately only as good as the weakest link in your supply chain. You need capable suppliers.
That really highlights how quality needs to cascade effectively through all the tiers of the supply chain. Okay, one more resource area. How do you ensure that when you measure something at a dimension, a performance characteristic, the measurement itself is accurate and reliable?
Excellent question. That's covered under the management of monitoring and measuring resources, which includes measurement tools. You need a comprehensive management system for all the equipment used for inspection, measurement, and testing that affects product conformity.
What does that system involve? Calibration.
Calibration is a key part, yes. You need processes for ensuring that measuring equipment is periodically calibrated or verified against measurement standards traceable to national or international standards. This confirms its accuracy. But IATF 16949 goes further, requiring measurement system analysis, or MSA.
MSA. What's that?
MSA is critical. It's a required set of techniques used to evaluate the entire measurement system, not just the gauge itself, but also the person using it, the appraiser, the procedure or method being used, the part being measured, and the environment. It aims to quantify the amount of variation or error present in the measurement process itself.
So calibration checks if the tool is accurate against a standard, but MSA checks how much error is introduced when you actually use the tool in your real-world process.
Exactly. You could have a perfectly calibrated gauge, but if the operators use it inconsistently, or the measurement procedure is flawed, or the fixture holding the part is unreliable, your measurement data will still be poor. MSA helps you understand and quantify those sources of measurement error. The goal is to ensure the data you're collecting is sufficiently reliable to make correct decisions about product conformity or process capability.
Because bad data leads to bad decisions.
Precisely. This applies particularly to internal and external laboratories performing critical tests or calibrations. They must demonstrate their technical competence, often through accreditation to the International Lab Standard ISO/IEC 1CO25 or specific customer approval. You need to maintain a defined scope and list of qualified labs you use.
Okay, that's a thorough look at resources. So we've got the system structure, the principles, the documentation, the controls, the resources. Now let's talk about the core activity, taking a product from an idea to reality on the production line. How does IATF 16949 structure this whole product realization process, especially the design and development part?
Product realization, particularly design and development, starts with careful and structured planning. For any new product introduction or significant change to an existing one, the standard requires you to define a plan for the design and development stages.
What goes into that plan?
It needs to outline the different phases of development, assign clear responsibilities, define timelines and milestones, identify the resources needed, people, tools, budget, and specify key review, verification, and validation points along the way. This planning phase must also consider the complexity of the product, all the applicable requirements, functional, performance, legal, regulatory, customer-specific, any lessons learned from previous similar projects, and proactively identify potential risks associated with the design or development process itself.
So a detailed roadmap before you even start designing. What kind of information feeds into this design process? What are the inputs?
The design inputs must be comprehensive, clear, and unambiguous. This includes all the functional and performance requirements for the product, applicable legal and regulatory requirements like safety standards or environmental regulations, relevant information derived from previous similar designs, lessons learned, warranty data, and again, those critical customer-specific requirements, CSRs.
Okay.
A very special focus within design inputs is on identifying special characteristics. These are product characteristics or manufacturing process parameters that are so important that variation in them is likely to significantly impact safety, compliance with regulations, product function, fit, form, or appearance. Identifying these early is crucial because they require specific, heightened controls throughout design and manufacturing.
Special characteristics, the things that absolutely positively cannot go wrong.
Got it. So those are the inputs. What comes out of the design process? What are the required outputs?
The design outputs must be documented in a way that allows them to be verified against the inputs. Did we meet all the requirements?
What form do these outputs take? They typically include things like defining clear acceptance criteria for the product, detailing those identified special characteristics, providing complete technical specifications, drawings, material specs, and critically, performing failure mode and effects analysis, FMEA, which is one of those key core tools we'll discuss specifically design, FMEA, DFMEA, to proactively analyze potential failure points in the design itself. Design outputs also encompass reliability studies, packaging specifications, and all the information needed for purchasing, production planning, and service activities downstream.
So the output isn't just the blueprint or the CAD model, but also a thorough risk analysis like the FMEA and detailed specs for everything else. How do you actually confirm the design works as intended?
That happens through structured verification and validation activities. These are distinct but related concepts.
Verification versus validation. What's the difference?
Verification activities confirm that the design outputs have met the design input requirements. Essentially, did we design the product correctly based on the specifications? This might involve design reviews, calculations, simulations, or comparing the design to proven designs. Validation, on the other hand, confirms that the final product, as designed, meets the needs of its specified application or intended use under real-world or simulated operating conditions. Essentially, did we design the right product for the job?
Okay, verification checks against the specs. Validation checks against the real-world use.
Exactly. Validation often involves rigorous testing of prototypes or early production parts under simulated or actual operating conditions like durability testing, crash testing, environmental testing. Both verification and validation activities must be planned, performed according to the plan, and the results fully documented.
Design work often involves lots of different departments working together: engineering, manufacturing engineering, quality, purchasing. How does the standard address those handoffs and interactions?
Managing the interfaces between different groups involved in the design and development process is crucial, and the standard requires it. Effective communication and coordination mechanisms must be in place, especially when transferring design information from engineering to the manufacturing teams.
How is that typically managed?
Often through structured design reviews involving representatives from all relevant functions like manufacturing, quality, purchasing, service, at key milestones. It's also managed through controlled document management systems that ensure everyone is working from the same up-to-date information. The goal is to ensure manufacturability, testability, and serviceability are considered early on, not just pure design function.
Makes sense. Get production involved early. And just like in production processes, design isn't always static. Things change. How are design changes managed?
Just like production changes, design change management requires a formal, documented process. Any proposed change to the product design after it has been initially approved must be identified, documented, thoroughly reviewed, considering its impact on function, fit, form, reliability, regulations, etc., and formally approved before it is implemented.
Approval needed first.
Yes, and there's particular emphasis on identifying and managing changes that require notification to or specific approval from the end customer. This ensures that changes are evaluated for potential impact on the vehicle system or customer expectations and don't introduce new risks or issues downstream in manufacturing or in the field. Uncontrolled design changes are a major source of problems.
Okay, so design is planned, executed with verification and validation, interfaces are managed, and changes are strictly controlled. Now let's move from the design office to the factory floor and the wider supply chain. What does IATF 16949 require specifically for purchasing activities and controlling production itself?
Okay, purchasing under IATF 16949 starts with rigorous supplier monitoring. You need a defined process and system to continuously track and evaluate the performance of your external suppliers.
How do you track them?
Typically using KPIs focused on critical aspects like the quality of the products or services they deliver. Example, defect rates, parts per million, or PPM. Their on-time delivery performance, their responsiveness to issues, and sometimes cost factors as well. This monitoring often includes classifying suppliers based on their performance levels. For example, approved, conditional, disapproved, and having defined escalation plans for those suppliers who consistently fail to meet requirements.
So you know who your good suppliers are and who needs attention.
Exactly. Effective two-way communication is also required. You need to provide regular performance feedback to your suppliers, and they need to communicate effectively with you about potential issues or changes on their end.
Okay, ongoing monitoring. But before you even start receiving mass production parts from a supplier for a new program, there's that critical approval process you mentioned earlier, right? PPP.
Yes, absolutely. The Production Part Approval Process, or PPP, is a cornerstone requirement for purchasing and launching new parts. Before a supplier can begin shipping mass production quantities of a new part or a part that has undergone a significant design or process change, they must successfully complete the PP process and get formal approval from you, their customer.
And what's the purpose of PPP again?
It's where the supplier formally demonstrates, with objective evidence, that they fully understand all the customer's engineering design records and specification requirements, and that their manufacturing process has the capability to consistently produce parts meeting those requirements during an actual production run at the quoted production rate.
So proof they can make it right, consistently, and at volume.
Precisely. It involves the supplier compiling and submitting a comprehensive package of documentation, things like design records, test results, material certifications, process capability studies using SPC data, measurement system analysis MSA results, appearance approvals if needed, sample parts, and a signed declaration called the Part Submission Warrant, PSW. We'll dive deeper into PPUP when we discuss the core tools.
Okay, PP feels like the official green light for suppliers. Is it just about checking up on suppliers, or is there a role for helping them improve too?
It's definitely both. While monitoring and PP are key control points, the standard also strongly emphasizes supplier development. This involves proactively working collaboratively with your key suppliers to help them improve their own quality systems, manufacturing processes, and overall capabilities.
What might that look like?
It could take many forms, providing specific training on quality tools or techniques, offering technical support from your engineers, sharing best practices you've developed, setting up joint continuous improvement projects, or transferring specific know-how. The ultimate goal is to build a more robust, capable, and resilient supply base that contributes positively to your own quality and performance. It's about partnership, not just policing.
Building a stronger chain together.
Mm-hmm.
Okay, so the materials and components are coming in from approved, monitored, and possibly developed suppliers. Now let's focus on the production floor itself. What are the key quality controls required during manufacturing?
Several critical controls are mandated. One important area is tool management. You need structured systems for managing all production tooling, things like molds, dies, jigs, fixtures, patterns.
Does managing them involve?
It includes ensuring they are properly identified, stored securely, regularly maintained to prevent wear or damage, and traceable. There are specific procedures required if the tooling is owned by the customer, ensuring their assets are protected and maintained according to their requirements. Proper tool management is essential for consistent part quality.
Makes sense. Worn tooling means bad parts. What else?
Another absolutely fundamental requirement is the implementation and use of statistical process control, or SPC. As mentioned, SPC is one of the key core tools, and we'll detail it more later, but its application in production is mandated by IATF 16949.
And the goal of SPC on the floor?
You use statistical methods, primarily control charts, to monitor and control the critical characteristics of your product and the key parameters of your manufacturing processes, those characteristics identified in your control plans, often flowing from your FEAs. SPC helps you understand if your process is stable and operating predictably within its expected range of variation. More importantly, it allows you to identify trends, shifts, or other non-random patterns that indicate potential issues or special causes of variation are present before they result in producing non-conforming parts. It's a predictive and preventive tool.
So using data in real time to predict and prevent problems during the actual production run, that's powerful. What about keeping the machinery itself, the production equipment, running reliably.
Preventative maintenance plays a absolutely central role here. You are required to have a documented total preventive maintenance TPM system for key production and testing equipment.
What does that involve?
It includes having a planned schedule for maintenance activities based on things like usage or time, managing critical spare parts to minimize downtime, and ideally incorporating predictive maintenance methods where feasible, like using sensors to monitor equipment health and predict failures before they happen. It also requires analyzing the effectiveness of your maintenance program using metrics like mean time between failure, MTBF, and overall equipment effectiveness, OEE, to drive improvements.
So not just doing maintenance, but proving it's effective in preventing breakdowns.
Exactly. Keeping the equipment capable and reliable is fundamental to achieving consistent quality and production output.
Okay, equipment maintained. What about handling materials and parts within the plant? Moving things around, storing them.
Internal logistics and material handling also have specific requirements. This includes robust systems for identifying and maintaining traceability of product throughout your facility, knowing what batch of material went into which finished product. It requires ensuring materials are used on a first-in, first-out FIFO basis, especially for materials with a limited shelf life to prevent obsolescence.
FIFO. Makes sense.
It also covers requirements for handling and storage methods designed to prevent damage or deterioration of materials and products. And managing overall inventory levels effectively is part of it, too.
And checking the product as it goes through the process.
Yes. Product verification is required. You need to verify product conformity at appropriate stages of your production process, as defined in your control plan, and perform final inspection or testing before shipment to the customer, ensuring all requirements are met. And, of course, records of these verification activities must be maintained.
Okay, lots of controls in place. But even with the best systems, things can occasionally go wrong. Parts get made that don't meet the spec. How does IATF 16949 ensure these problems are handled effectively and, crucially, don't reach the customer?
Handling non-conforming outputs is indeed a critical process with very stringent requirements in the standard. The absolute first step is rapid identification and segregation.
Find it and isolate it fast.
Exactly. You must have systems in place to quickly detect any product that doesn't meet specifications, whether found during production, inspection, or testing. Once identified, it must be clearly marked and physically isolated in designated controlled areas, often called quarantine or non-conforming material areas, to prevent it from being accidentally mixed with good product, used in further processing, or shipped inadvertently.
Visible control.
Yes, visual systems are often used, and importantly, personnel must be trained and explicitly authorized to stop production or stop shipment if a quality issue is found. Empowering operators is key here.
Okay, stop the line if necessary. Problem identified, part isolated. Then what?
Then you need thorough documentation and resolution. Every instance of non-conforming product must be documented: what was wrong, how much, when was it found. The immediate cause needs to be investigated and a process for corrective action initiated to prevent recurrence. Then comes the disposition decision. There must be a clearly defined process involving authorized personnel, sometimes including customer representatives, especially for critical issues, to decide what happens to the non-conforming product. The options are typically rework, repair, which has very strict limitations and often requires customer approval, except as is under a formal concession from the customer, or scrap.
And the decisions are taken lightly.
Absolutely not. The disposition process must be rigorously controlled, especially for characteristics related to product safety or regulatory compliance. Unauthorized use or repair of non-conforming product is a major violation.
Okay. What about product that you're not sure about? It's not confirmed bad, but it looks suspicious.
That's covered under suspect product control. You need procedures for the rapid identification and containment of products that is potentially non-conforming, even if you haven't confirmed it yet. This might involve blocking entire lots, conducting supplementary inspections or tests, or implementing other containment measures. Your control plan should ideally define reaction limits, triggers based on process data showing negative trends that initiate these containment actions proactively.
So act quickly, even on suspicion. Don't wait for proof if the risk is high. What about situations where you know a part is slightly out of spec, but you think it might still be usable? Can you just ship it?
No, definitely not. That requires managing concessions or deviations. If you need to ship product that deviates from the approved specifications, you must obtain formal, documented approval, a concession from the customer before shipment.
Customer has to agree first.
Yes. And this requires meticulous documentation detailing the exact nature of the deviation, the quantity of product affected, the duration or validity period of the concession, and evidence of the customer's formal approval. Records of all concessions granted must be maintained and analyzed periodically to identify opportunities to eliminate the root causes that necessitated the deviation in the first place.
Okay, concessions are tightly controlled. What about rework, if you can fix the non-conforming part?
Rework control is also strictly required. If rework is permitted, and it might not be for all characteristics or products, there must be documented work instructions detailing exactly how the rework is to be performed. These instructions must be approved by qualified personnel and sometimes require customer approval as well.
And after rework?
Reworked products must be fully re-inspected or retested according to the original requirements, or an approved plan to ensure they now meet all specifications. The rework process itself must not negatively impact the product's function, performance, durability, or appearance. Traceability of reworked product must be maintained, and that causes leading to the need for rework should be analyzed as part of continuous improvement efforts.
This sounds like a very rigorous framework for dealing with problems when they arise.
No.
But the real goal is prevention, right?
Hmm.
How do you ensure you fix the underlying issue so the problem doesn't just keep happening again and again?
Exactly. Dealing with the non-conforming product is containment. Fixing the root cause is improvement. That's the core of problem solving in IATF 16949. The standard requires a defined, documented, and methodical process for problem solving, aimed squarely at identifying and eliminating the root cause of the nonconformity.
A methodical process,
Yeah.
not just reacting.
Correct. Key personnel must be trained in structured problem-solving methodologies. And a crucial requirement here is the system for sharing lessons learned. When you solve a problem in one area, that knowledge needs to be disseminated across the organization and applied preventively to similar processes or products elsewhere to stop the same issue from popping up unexpectedly.
That makes sense. Learn once, apply everywhere. How do you actually find that elusive root cause? It's often not obvious.
Finding the root cause is the analytical heart of effective problem solving, and it's often the hardest part. The standard mandates the use of structured methodologies. Common ones used in automotive include the 5 Whys, Ishikawa or fishbone diagrams, fault tree analysis FTA, or the comprehensive 8 disciplines 8D process.
Using tools to dig deeper.
Yes. The goal is to drill down beyond the superficial symptoms to find the fundamental reason the problem occurred. This often requires looking at both technical causes, for example, machine setting drifted, and potential systemic issues within the quality management system or processes, for example, inadequate training, poor procedure, flawed FMEA. Multidisciplinary teams bringing different perspectives are often essential for effective root cause analysis. And a key step often missed is verifying with objective evidence that the root cause you've identified actually explains the observed problem. Don't just assume.
Okay, you've used your 5 Whys or your fishbone diagram. You think you found the true root cause. What then?
Then you define and implement appropriate corrective actions. These are the actions designed specifically to eliminate that identified root cause. These actions must be systematically implemented with clear responsibilities assigned, realistic deadlines set, and necessary resources allocated.
And you just assume the actions worked.
Absolutely not. A critical step mandated by the standard is to verify the effectiveness of the implemented corrective actions after a suitable period of time has passed. You need to gather objective data to confirm that the root cause has indeed been eliminated and that the problem is not recurring. Closing out a corrective action without verifying effectiveness is a common audit finding.
Verification of effectiveness closed the loop.
Precisely. And one particularly powerful tool related to both corrective action and prevention is error proofing, often referred to by the Japanese term poka-yoke.
Error proofing, making it impossible to mess up.
That's the ideal, yes. The standard puts specific emphasis on developing solutions, where feasible, that physically prevent a nonconformity from being produced or accepted, rather than just relying on human inspection or detection after the fact. Examples might be fixtures that only allow a part to be inserted the correct way, or sensors that stop a machine if a required component is missing.
Designing the error out.
Exactly. Organizations should maintain a catalog or list of their error-proofing devices and methods, verify their effectiveness periodically, for example, testing them at the start of each shift or during changeovers, and ensure they are properly maintained.
That sounds very effective. And back to when a problem is first found, immediate action is needed to protect the customer, right? Even before you find the root cause.
Yes, that's containment. The standard requires immediate action, ideally within 24 hours, of detecting a nonconformity or suspect product to contain the problem and prevent affected product from reaching the customer. These containment actions, like sorting inventory, implementing temporary inspections, must also be verified for their effectiveness.
And containment is temporary.
Yes, containment actions are typically temporary measures put in place until permanent corrective actions addressing the root cause have been fully implemented and validated. Timely and transparent communication with the customer regarding containment actions is also critical, especially if the issue is identified through a customer complaint or field failure.
Okay, containment, root cause analysis, corrective action, verification, error proofing, lessons learned. A very structured approach to problems. Now, this whole system, especially the prevention side, sounds like it relies heavily on a specific set of tools and methods. And that brings us to something absolutely fundamental in IATF 16949 that you've mentioned a few times.
Yeah.
The automotive core tools. What exactly are these and why are they considered so essential?
You're right. The core tools are foundational. They are a set of 5 key methodologies that are explicitly required or referenced by IATF 16949. They really form the backbone of effective automotive quality planning, risk reduction, process control, and product approval. If you're working in or supplying to the automotive industry, you absolutely need to understand and use these tools effectively.
5 key methodologies. What are they?
They are APQP, FMEA, SPC, MSA, and PPAP. Think of them as the standard essential toolbox for achieving and maintaining quality in the demanding automotive environment.
Okay, APQP, FMEA, SBC, MSA, PPP. Let's unpack each one briefly. First up, APQP.
APQP stands for Advanced Product Quality Planning. Its core purpose is to provide a structured framework, a kind of roadmap for planning and developing new products and their associated manufacturing processes.
A roadmap for new product launch.
Exactly. It's a phased approach typically described with 5 phases. 1, planning and definition. 2, product design and development. 3, process design and development. 4, product and process validation. And 5, feedback, assessment, and corrective action. Each phase has defined activities, required inputs, expected outputs, deliverables, and key review milestones. The goal is to ensure that potential issues are identified and addressed early in the development cycle, guaranteeing that all customer requirements, quality, timing, cost, are met throughout the product's life cycle.
And who's involved in APQP?
A key element mandated by the approach is the use of a multidisciplinary team, often called a cross-functional team, or CFT. This team should include representatives from all relevant functions right from the start: design engineering, manufacturing engineering, quality, purchasing, logistics, sales, service, sometimes even suppliers, and the customer. This ensures all perspectives and requirements are considered early on, preventing problems later.
So APQP is the overarching plan that pulls everyone together early and guides the whole development process.
Precisely. You can think of APQP as the container or the master plan that provides the structure for using the other core tools at the appropriate stages of development. It documents the progression, key decisions, risk assessments, and validation results throughout the launch process.
Okay, that makes sense. Next up, FMEA. We touched on design FMEA earlier. What is FMEA more broadly?
FMEA stands for Failure Mode and Effects Analysis. This is a proactive, systematic, analytical tool used to identify potential ways a product or a manufacturing process could fail. These are the failure modes. Then, for each potential failure mode, you analyze its potential causes and its potential effects on the customer or downstream processes.
Why do this analysis?
The goal is to identify potential risks before they happen and implement preventative actions to either reduce the likelihood of the failure occurring in the first place or increase the chance of detecting the failure if it does occur, or both. It's a cornerstone of risk management in automotive.
Are there different types of FMEA?
Yes, the 2 main types required are Design FMEA, DFMEA, which focuses on potential failures related to the product design itself, and Process FMEA, PFMEA, which focuses on potential failures in the manufacturing or assembly process used to make the product.
And how do you prioritize which potential failures are the most serious and need action first?
Traditionally, FMEA involved calculating a risk priority number, or RPN. This was done by assigning numerical scores, typically 1 to 10, for the severity S of the potential effect, the likelihood of occurrence, O of the cause, and the likelihood of detection, D of the failure or cause using existing controls. The RPN was simply SXOXD. Higher RPNs indicated higher risk areas needing priority attention.
Okay, S times O times D. Is that still how it's done?
The methodology has evolved. The latest standard, developed jointly by AIAG US and VDA Germany, introduced the AIAG VDA FMEA handbook. It defines a more structured seven-step process and uses action priority, high, medium, low, instead of RPN, to guide prioritization, considering S, O, and D ratings together based on logic tables. But the fundamental goal remains the same: identify and prioritize risks for preventive action.
So the method evolved, but the goal is still risk reduction.
Exactly. And FMA isn't a one-time activity you do and file away. It's intended to be a living document. It must be reviewed and updated whenever there are changes to the design or process, when new failure modes are discovered, for example, from testing or field data, or as part of continuous improvement efforts. A crucial output of both DFMEA and PFMEA is the identification of those special characteristics we discussed earlier, the critical features requiring heightened control. These feed directly into the next tool.
Okay. FMEA helps you proactively spot potential problems and identify what needs special control. How does SPC connect to this?
SPC, Statistical Process Control, is the tool you use during manufacturing to monitor, control, and improve your production processes, particularly focusing on those special characteristics identified through FMEA or other risk analyses. It uses statistical methods to help you understand the variation inherent in your process.
Understanding variation.
SPC helps you differentiate between the two types of variation present in any process: common cause variation, the natural random noise inherent in a stable process, and special cause variation, variation resulting from specific identifiable causes outside the normal process, indicating something has changed or gone wrong.
And the main visual tool for SPC is the control chart.
Yes, the control chart is the primary tool. It's basically a run chart of a process characteristic, like a dimension, temperature, or defect rate, plotted over time, with statistically calculated upper and lower control limits added. These limits typically represent plus and minus 3 standard deviations from the process average when it's stable.
What do the control charts tell you?
By looking at how the data points fall relative to the control limits in the center line, and by analyzing patterns in the data, like trends, shifts, cycles, points outside the limits, you can determine if the process is statistically in control, stable and predictable, or out of control, affected by special causes. If it's out of control, it's a signal that investigation and corrective action are needed immediately.
Okay, so it's an early warning system.
It is. SPC is also used to evaluate process capability, measuring how well your process, even when stable, is inherently capable of meeting the specified requirements or tolerance limits set by engineering. This is often expressed using indices like CP, CPK, PP, and PPK, with specific minimum acceptable values typically required by automotive customers. For example, CPK 1.33 or 1.67.
So is the process stable, and is it capable?
Those are the key questions SPC helps answer. The standard requires defining and documenting reaction plans or out-of-control action plans, OCAPs, that specify the immediate steps personnel must take when a control chart shows an out-of-control signal or an undesirable trend. These plans need to be readily available and followed.
Okay, SPC tells you if your process is behaving itself, but all that data collection and analysis relies heavily on having accurate measurements in the first place, right? Which brings us back to MSA.
Precisely. MSA, measurement system analysis, is absolutely critical because it evaluates the quality, reliability, and statistical properties of your measurement system itself. If your measurement data is faulty or has too much error, then any analysis you do with SPC will be misleading, and any decisions you make about product conformity based on that data could be wrong. You might reject good parts or accept bad parts.
So MSA quantifies the error in the measurement.
Exactly. It quantifies the amount of variation or error introduced by the measurement process, distinguishing it from the actual variation in the production process you're trying to measure. A good measurement system should have significantly less variation than the process it's measuring.
What are the main things MSA looks at? What contributes to measurement error?
MSA takes a holistic view, considering potential sources of variation like the measuring instrument or tool itself, its inherent precision, the operator or appraiser using the tool, differences between operators, the measurement method or procedure being followed, the specific samples being measured, and even the environmental conditions like temperature or cleanliness.
Okay, it's a whole system.
Yes. For measurement of physical dimensions, what's called variable data, a primary MSA tool is the Gauge Repeatability and Reproducibility, Gauge R&R study. This specifically assesses the variation coming from the measuring equipment itself. Repeatability variation when one operator measures the same part multiple times, and the variation coming from different operators using the same equipment. Reproducibility variation when different operators measure the same part.
Gauge R&R sounds technical.
It is a statistical study, yes. It calculates metrics, like the percent GR, which tells you what percentage of the total observed variation is due to the measurement system. There are established acceptability criteria. For example, GRR below 10% is generally considered good, over 30% is usually unacceptable. MSA techniques also exist for attribute data, go-no-go gauges, or visual inspection, looking at things like effectiveness, bias, and agreement between appraisers.
And how does MSA relate to calibration? Are they the same thing?
No, they're different but related. Calibration primarily checks the accuracy of a measuring instrument against a known, traceable standard at specific points. MSA goes further. It assesses the overall performance and variation of the measurement system as it's actually used in your specific environment with your specific operators and procedures. A gauge can be perfectly calibrated but still be part of a poor measurement system if it's difficult to use or operators aren't trained properly.
Okay, so MSA validates the quality of the data you're using for SPC and capability studies and for accepting product. It ensures you can trust your numbers.
That's the essence of it. It's a prerequisite for reliable SPC and process improvement.
Got it. So APQP plans the launch, FMEA identifies risks up front, MSA validates the measurement system, SPC monitors the process during production, and finally, PPP, the gatekeeper we discussed in purchasing. Tell us more about its role as a core tool.
Right. PPP, the production part approval process, serves as the standardized process for the formal qualification and approval of new or significantly changed components and their associated manufacturing processes before they are used in mass production. It's essentially the culmination and evidence package from the APQP process.
What's its main purpose? Building confidence.
Yes, exactly. It provides documented evidence to the customer that the supplier has understood all the engineering design record and specification requirements and that their manufacturing process has the demonstrated potential to consistently produce product meeting these requirements during an actual production run at the quoted production rate. It builds confidence on both sides before committing to high-volume production.
When exactly is PPP required? Only for brand new parts.
It's required before the first mass production shipment of any new part. But it's also required after certain significant changes are made to an already approved part or process. Examples include changes in design, materials, tooling, manufacturing location, process parameters outside the range verified in the original PPP, or even changes in the supplier's own sub-suppliers for critical inputs. Any change with the potential to affect fit, form, function, durability, or performance typically requires a new PP submission and approval.
So it reinforces that change control discipline. What are the typical steps in the PPP process?
Generally, it involves the supplier planning for PPP as part of APQP, then preparing all the required documentation. There are 18 standard elements defined in the PP manual, covering everything from design records to FEAs, control plans, test results, capability studies, MSA studies, and sample parts. The supplier performs a significant production run, collects data, performs required tests, and compiles the PP package. This package, or parts of it, depending on the submission level, is then submitted to the customer for review and approval.
18 standard elements.
Yeah.
Sounds comprehensive. You mentioned submission levels.
Yes, the PPP standard defines 5 levels of submission. Level 1 is the simplest, often just requiring submission of the part submission warrant, PSW, and maybe appearance approval reports. Level 3 is considered the default and requires submission of the PSW with a summary of supporting data and sample parts, while the full supporting documentation is retained by the supplier and readily available for review. Level 5 is the most rigorous, requiring submission of the full package and samples, often with review at the supplier's manufacturing location. The required level depends on factors like the criticality of the part, its complexity, the supplier's history, and specific customer requirements.
Okay, different levels of scrutiny. And the PSW, the part submission warrant, what's its significance?
The PSW is the central summary document in the PPP package. It's where the supplier formally declares that the parts submitted meet all specified requirements, that all required documentation is complete and available, and that their process is capable. It requires an authorized supplier representative's signature, essentially taking responsibility for the conformity and capability demonstrated in the PPP package. It's a formal certification.
So signing the PSW is a serious commitment.
It absolutely is. And as we said, any significant change after initial PPP approval requires a new PP submission and customer approval before the changed parts can be shipped for production use. This ensures ongoing control.
Does PPP apply down the supply chain too? Do suppliers need PPP from their own suppliers?
Yes, that's another crucial aspect. The PPAY requirement cascades down. Organizations certified to IATF 16949 are required to obtain TPAP approval from their own suppliers for critical components or materials that go into the product they supply to their customer. It ensures control and verification throughout the tiers.
Wow. Okay, so the core tools really work together as an integrated system. APQP provides the overall plan. FMEA proactively identifies and mitigates risks. MSA ensures measurement reliability. SPC monitors and controls the process in real time. And PPP provides the final evidence and approval that the whole system works before mass production begins.
That's an excellent summary of the synergy. They are interconnected methodologies, each supporting the others, all aimed at preventing problems, ensuring capable processes, and meeting customer requirements consistently. Effective implementation of the core tools is absolutely fundamental to success with IATF 16949.
Okay, we've built the system, documented it, resourced it, put the production controls in place, and we're using the core tools. How do you keep the system healthy over time? How do you know if it's actually working effectively day to day where you need to improve?
That's where ongoing performance evaluation and, critically, audits come into play. Audits are the primary mechanism for systematically checking conformance to the requirements of the standard and, just as importantly, assessing the overall effectiveness of your quality management system. Is it achieving the intended results?
What types of audits are required by IATF 16949?
There are three main types you need to be concerned with. First, internal audits. These are audits conducted by your own organization using your own trained auditors to assess your own processes, your overall system conformance, and sometimes specific products against requirements.
Checking up on yourself.
Exactly. Second, there are second-party audits. These are typically audits conducted by your organization on your suppliers to verify their compliance with your requirements or IATF 16949 itself. And third, the big one, third-party audits. These are conducted by accredited independent certification bodies for the purpose of granting and maintaining your official IATF 16949 certification.
Let's talk about the internal audits first. How important are those for maintaining the system?
They are incredibly important for self-assessment and driving internal improvement. Your internal audit program must be comprehensive, covering all relevant processes and shifts over a defined cycle, often annually or based on risk. Importantly, the program must be risk-based.
Risk-based auditing, meaning?
Meaning you should plan your audit frequency and intensity based on the importance of the process, its past performance, any significant changes, customer feedback related to it, and identified risks. High risk or poorly performing areas should be audited more frequently or in more depth.
That makes sense. Focus where the risks are. What about the auditors?
Your internal auditors need to be competent. The standard has specific requirements for internal auditor competency, which includes not just general auditing techniques, but also a thorough understanding of the IATF 16949 standard itself, applicable customer-specific requirements, CSRs, the core tools, and risk assessment methods. They must also be objective and, where practical, independent of the specific area they are auditing to avoid conflicts of interest.
Okay, trained, knowledgeable, and independent auditors. And the big one is the third-party audit for the certificate itself. How does that work?
Yes. Third-party audits conducted by the certification bodies, CBs, follow very strict rules defined by the IATF itself, known as the Rules for Achieving and Maintaining IATF Recognition. These audits are typically very thorough and rigorous.
What's the audit cycle like?
For initial certification, it's usually a two-stage process. Stage 1 is a readiness review, often documentation review and checking preparedness, followed by Stage 2, which is the full on-site implementation audit. Once certified, you have regular surveillance audits, typically conducted every 6 or 12 months to ensure the system is being maintained and improved. Then, every 3 years, you undergo a full recertification audit to renew the certificate.
Sounds intensive. What happens if the auditors find something wrong during any of these audits? A nonconformity?
Managing nonconformities found during audits is handled very strictly according to those IATF rules. Nonconformities are classified based on their severity, typically as either major or minor.
Major versus minor. What's the difference?
A major nonconformity generally indicates a significant failure of the system. Perhaps a complete absence of a required process, a failure to implement a key part of the system, or a situation that could lead to shipping non-conforming product or seriously impact customer satisfaction. It might also be an accumulation of several breakdowns. Minor nonconformity is typically an isolated lapse or failure in execution that doesn't represent a systemic problem.
And the consequences differ.
Oh, significantly. The consequences are much more severe for majors. If a major is found, the organization must implement immediate containment actions and submit a detailed corrective action plan, including root cause analysis, to the certification body within a very tight time frame, often just 20 calendar days.
Wow, 20 days. That's fast.
It is, and the full corrective actions, including verifying their effectiveness, must typically be implemented within 90 days. This often requires a follow-up special audit by the certification body just to confirm the major has been effectively closed. Failure to meet these deadlines can lead to the suspension or even withdrawal of your IATF 16949 certification, which could mean losing business.
Serious stuff. And minors.
Minors also require documented root cause analysis and corrective action, but typically on a less urgent timeline, often 60 days for the plan. The effectiveness of the actions taken for minors is usually verified at the next scheduled surveillance or recertification audit, rather than requiring a special visit. However, repeated minors in the same area could be escalated to a major.
That sounds like a very strong mechanism to drive swift and, more importantly, effective corrective action. And it circles back to that root cause analysis again, doesn't it?
It absolutely does. The emphasis throughout the nonconformity management process, driven by the IATF rules, is always on conducting a thorough root cause analysis. Why did this failure really happen? Often requiring the use of those structured problem-solving methodologies from the core tools toolbox, like 8D. And just as importantly, providing objective verification of effectiveness. Did the fix actually solve the underlying problem permanently, or did we just patch the symptom? Leadership involvement and oversight are also expected for significant issues identified during audits.
Okay, so audits are the periodic health checks. Beyond audits, how do you use ongoing data to measure performance and drive continuous improvement?
Performance measurement and improvement is a continuous cycle, not just an audit-driven event. A key area the standard focuses on is monitoring customer satisfaction. You need structured methods to actively solicit, collect, analyze, and act upon customer feedback regarding your products and services.
How do you measure satisfaction? Surveys.
Surveys can be part of it, but IATF 16949 puts distinctive emphasis on monitoring performance related to deliveries from the customer, meaning how your performance directly impacts their operations. Key metrics here include your on-time delivery performance, the frequency of premium freight or expedited shipments you cause due to delays, any customer notifications related to quality or delivery issues, and particularly any occurrences of production line interruptions at the customer's plant caused by your product or delivery failures. You also need to monitor warranty performance and field claim data.
So, focusing on the real impact on the customer's business.
Exactly. Internally, data analysis is explicitly required. You need to collect and analyze data related to product conformity and process performance, using appropriate statistical methods, tying back directly to SBC and MSA, to understand variability, trends, and identify opportunities for improvement.
Using the data you're collecting.
Yes. This includes active process monitoring using KPIs for key production processes, and having predefined reaction strategies for processes that become statistically unstable or incapable of meeting requirements.
Okay. And what about labs? Testing and calibration activities.
The management of laboratories, both internal and external, performing tests or calibrations critical to product conformity is very important. Internal labs must operate according to documented procedures and must be able to demonstrate their competence. This often means meeting the requirements of the International Laboratory Standard, ISO/IE 17025, or having a documented scope that covers their capabilities, personnel competency, and method validation.
And external labs you use.
External labs must generally be accredited to ISO/IE 17025 for the specific tests or calibrations they perform for you, or they need to be formally approved by your customer. You are required to maintain a defined scope and list of the qualified internal and external labs you use. Ensuring the reliability of test and calibration results is fundamental.
Right. Garbage in, garbage out applies to test data too. Okay, audits and ongoing data analysis keep the system honest and pointed towards continuous improvement. Now let's tackle that extra layer of complexity you mentioned earlier. Dealing with those unique customer-specific requirements, CSRs, and also keeping up with official interpretations or updates from the IATF organization itself.
Yes, this is where navigating IATF 16949 gets particularly specific and challenging for many suppliers. Let's start with customer-specific requirements, or CSRs.
What are they exactly?
CSRs are additional quality management system requirements that are defined and imposed by individual vehicle manufacturers, the OEMs like Ford, GM, Toyota, VW, etc., or sometimes even by Tier 1 suppliers onto their own suppliers. These requirements supplement and sometimes significantly exceed the general requirements laid out in the IATF 16949 standard itself.
Well, wait, if the whole point of IATF 16949 was harmonization, to create one global standard, why do we still have all these individual customer requirements layered on top? It seems counterintuitive.
That's a very fair question. The reality is, despite the huge progress made in harmonization through IATF 16949, each OEM still operates with its own unique internal processes, engineering standards, legacy systems, specific commodity strategies, preferred methodologies like specific problem-solving formats or software, and critical lessons learned from their specific vehicle platforms and field performance history.
So they still have their own way of doing things.
To some extent, yes. The purpose of CSRs is to allow OEMs to formally incorporate those specific needs and expectations into the supplier's quality management system, ensuring that suppliers meet the particular requirements critical to that customer's business beyond the harmonized baseline of IATF 16949. They reflect the reality that while the quality system foundation is harmonized, there are still key differences in practice and priority among the major car makers.
Okay, so they supplement the standard. What's their official status? Are they mandatory?
Absolutely mandatory. Their relationship with IATF 16949 is crucial and explicit. The standard itself, in Clause 4.3.2, makes compliance with all applicable CSRs a normative requirement. This means that during a third-party certification audit, the auditors must verify that your organization has correctly identified, understood, implemented, and is complying with the CSRs for every automotive customer you supply. Failing to meet a CSR is equivalent to failing to meet a requirement in the standard itself. It will result in an audit nonconformity.
Wow. So you need to know the standard A&D, all the specific rules for each customer you sell to. Managing all those must be a huge challenge for suppliers.
It absolutely is. It's often cited as one of the primary management challenges for organizations implementing and maintaining IATF 16949. Think about it. A supplier might serve multiple OEMs. Each OEM might have its own CSR document, potentially running to hundreds of pages. These documents are often updated frequently, sometimes with little notice. And occasionally, requirements between different customers might even appear to conflict, requiring clarification.
How do companies even keep track?
It requires a very structured internal process. You need someone responsible for monitoring each customer's supplier portal or website for updates to their CSRs. When an update is published, you need a process to analyze the changes, assess their impact on your existing quality system and processes, plan and implement any necessary changes to procedures, work instructions, control plans, training, etc., and do it all quickly to remain compliant.
Sounds like a full-time job for someone.
For larger suppliers, it often is. An effective management strategy recommended in the source is to actively integrate the relevant CSR requirements directly into your own internal QMS documentation, your procedures, work instructions, forms, control plans, rather than just keeping the customer's CSR documents separate on a shelf. This helps embed the requirements into daily operations and makes them easier for personnel to follow.
Integrate, don't just reference.
Exactly. And the impact of managing CSRs effectively is significant. It's not just about passing audits. Meeting or exceeding CSRs directly impacts your performance ratings with that customer, which in turn influences their decisions about awarding future business. Ignoring CSRs is simply not an option if you want to succeed long-term in automotive.
Okay, so IATF 16949 provides the global baseline, and then each customer adds their specific layer through CSRs. That's one source of extra rules. What about official clarifications or changes coming directly from the IATF organization itself? How are those handled?
Those are handled through official documents called sanctioned interpretations, or SIs. These are published periodically by the IATF organization.
Sanctioned interpretations,
Yeah.
What's their purpose?
Their primary purpose is to clarify the intent of existing requirements within the IATF 16949 standard, or sometimes to modify existing requirements or even introduce new ones based on feedback, common audit findings globally, or emerging industry issues. The goal is to ensure consistent and uniform understanding and application of the standard across all certified organizations, auditors, and certification bodies worldwide. They help resolve ambiguities.
So they're like official patches or FAQs for the standard.
That's a good analogy. The process for developing and approving SIs is quite rigorous, involving input from the IATF member OEMs, supplier representatives, and certification bodies, with final approval by the IATF Global Oversight Committee.
And once an SI is published, what's its status?
Its applicability is generally immediate, or based on a specified implementation date within the SI document. Once published and effective, an SI becomes an integral and auditable part of the IATF 16949 standard. Certification bodies must evaluate organizational compliance with all applicable SIs during audits. Therefore, organizations certified to IATF 16949 must have a process in place to monitor for the release of new SIs, review them, and ensure they are implemented by the required date. Ignorance is not an excuse.
So you have to keep up with SIs, just like you have to keep up with CSRs. Can SIs have a big impact?
Yes, the impact of SES can be quite significant. They might require changes to your documented processes, your procedures, your training materials, auditor competencies, or even resource allocation. Failing to comply with an applicable SI will result in an audit nonconformity, just like failing to comply with a clause in the main standard or a CSR.
Can you give any examples of topics covered by recent SIs?
Sure, the source mentions a few illustrative examples. For instance, SI 19 dealt with clarifying requirements around managing external documents, particularly customer specifications. SI 20 introduced clarifications related to product safety notifications and escalation processes. SI 21 addressed requirements for internal auditor qualification and ongoing evaluation. And SI 22 highlighted the need to include considerations like cybersecurity, data protection, and supply chain interruptions within the organization's risk analysis processes.
So they can touch on really current important topics like cybersecurity.
Absolutely. They keep the standard relevant. And just like with CSRs, effective management of S requires a structured internal process. Monitor for new releases, analyze the impact on your QMS, plan and implement any necessary changes, verify the effectiveness of those changes, and document the whole process. You need to stay current.
Okay, so managing IATF 16949 means managing the core standard, plus customer specifics, CSRs, plus official updates. It definitely sounds like implementing and maintaining all of this is a significant undertaking. What are some of the most common real-world challenges companies typically face when putting IATF 16949 in place or keeping it effective? And what strategies does the source suggest they use to overcome them?
You're absolutely right. It's not a trivial task, and companies do face common hurdles. One recurring challenge is simply interpretation. As we've just discussed, understanding exactly what a specific requirement means, especially when you have to weave together the standard itself, multiple SIs, and potentially conflicting CSRs from different customers, can be genuinely complex and sometimes ambiguous.
How do companies deal with that ambiguity?
The strategy involves several things. Thorough training for key personnel is essential. Sometimes seeking guidance from experienced external consultants or trainers can help. Participating in industry working groups or forums where interpretations are discussed can be valuable. And importantly, having open dialogue with your certification body between audits to clarify interpretations before they become nonconformities is often a good approach.
Okay, clarify up front. What's another big challenge?
Another very common one is the integration with existing processes. Many companies, especially those with established ways of working, worry that implementing IATF 16949 will just add layers of bureaucracy and paperwork on top of what they already do, creating parallel systems that aren't efficient.
The binder on the shelf syndrome.
Exactly. The key strategy here is to focus on integrating the IATF requirements into your existing business processes wherever possible, rather than creating a separate quality system. This often requires analyzing and sometimes redesigning your current processes to embed the necessary controls and documentation naturally. Implementing changes in phases, leveraging digital tools to streamline workflows, and periodically reviewing and simplifying processes can all help avoid excessive bureaucracy.
Documentation management itself seems like it could easily spiral out of control.
It's definitely a challenge mentioned in the source. The standard does require extensive documented information and keeping it all up to date, ensuring the correct versions are always being used at the point of use, and avoiding the creation of unnecessary documents requires discipline.
Strategies for that.
Digital document management systems are increasingly becoming the standard solution. They offer built-in version control, automated workflows for review and approval, easy searchability, and controlled access, which helps immensely. Having a clear hierarchy for documents, e.g. manual procedures, work instructions, work forms records, and using visual formats where appropriate can also help. Regular reviews to identify and archive obsolete documents are also important housekeeping.
Okay, digital tools help manage the paper monster. What about using those core tools effectively? Is that a challenge?
Yes, actually applying the core tools, APQP, FMEA, SPC, MSA, PPP, in a substantial and value-adding way, rather than just formally going through the motions to create the required paperwork, is a major hurdle for many organizations. They can seem complex and time-consuming if not properly understood or implemented.
How do companies get real value from them?
Strategies include investing in in-depth, practical, often certified training on each core tool, not just a quick overview. Assigning internal subject matter experts or champions for each tool to coach teams can be very effective. Conducting pilot projects on specific products or processes to build experience is useful. And utilizing specialized software designed specifically for tools like FMEA, SBC, and MSA can make them much more efficient, data-driven, and easier to integrate into daily work.
Okay, deep training and good tools help. What about shifting the whole organization's mindset towards that proactive, risk-based thinking that seems central to IATF 16949?
That can be a significant cultural shift, absolutely. Developing robust and consistent methodologies for a systematic risk-based approach across the entire organization, beyond just doing FMEAs for new products, is challenging. People are often more comfortable reacting to problems than proactively anticipating them.
The strategies for embedding risk thinking.
Strategies involve potentially extending risk analysis techniques like FMEA to other areas, for example, supply chain risks, project risks. Developing standardized risk assessment tools or matrices to ensure consistency helps. Most importantly, integrating risk considerations explicitly into routine decision-making processes, from strategic planning to daily operational meetings. Using multidisciplinary teams for risk assessment brings diverse perspectives.
Make risk assessment part of the routine. What about getting and keeping the bosses on board?
Maintaining genuine leadership support is absolutely crucial, but can be a challenge, especially after the initial certification push. Implementation requires investment, resources, and effort, and sometimes focus can drift if top management isn't visibly and consistently demonstrating commitment.
How do you keep leadership engaged?
Strategies include clearly demonstrating the tangible business value and ROI of the quality system, showing how it reduces costs, improves efficiency, or wins business. Ensuring leaders are actively involved in key QMS processes like management reviews and objective setting is vital. Linking quality performance metrics directly to management performance objectives can help. And providing regular, concise reporting on QMS performance and its contribution to business goals keeps it on their radar.
Show them the money. Involve them directly. How do companies handle the constant tension between the demands of quality and the relentless pressure for speed, productivity, and cost reduction in automotive?
The classic quality versus productivity balance. This is a persistent challenge in high-volume, cost-sensitive manufacturing. The strategy is not to see quality as separate from or opposed to productivity. Instead, it's about integrating quality controls and considerations directly into the production planning and execution processes.
How does that work?
Using lean manufacturing principles often helps significantly, as reducing waste, scrap, rework, waiting time, unnecessary motion inherently improves both efficiency and quality. Designing processes for quality upfront using APQP and FMEA prevents costly issues later. Implementing effective SPC helps catch problems early before large quantities of bad product are made. And clearly demonstrating the cost of poor quality, COPQ, quantifying the money wasted on failures, inspections, and fixes, helps make the economic case that investing in proactive quality actually saves money and improves overall productivity in the long run. Using balanced metrics that consider both quality and efficiency is also key.
So quality enables productivity. It doesn't hinder it, if done right.
That's the message to convey. Finally, another challenge, especially in dynamic environments, is managing competence. Developing and maintaining the necessary skills and knowledge across the workforce can be difficult, especially with employee turnover or the rapid evolution of technology and processes.
Strategies for keeping competence high.
Strategies include implementing structured training plans and matrices linked to job roles. Having robust knowledge management systems to capture and share expertise is important. Creating clear career paths for quality professionals helps retention. Establishing communities of practice or internal mentorship programs can foster continuous learning and skill development.
So, a systematic approach to skills and knowledge. Are there specific examples in the source of companies that have successfully navigated these kinds of challenges?
Yes, the source provides a few illustrative case studies without naming specific companies. One example involved a supplier of plastic components for interiors. Their challenge was inconsistent application of controls across shifts. They overcame this by focusing heavily on extensive, practical, hands-on training for operators and engineers, directly linking classroom learning to shop floor application of core tools like SPC and visual management techniques like 5S, reinforced by daily team meetings.
So practical reinforced training.
Exactly. Another case involved a global electronics supplier with multiple manufacturing sites, each with slightly different legacy systems. Their challenge was harmonizing their QMS to meet IATF 16949 consistently worldwide. Their strategy involved developing a central corporate QMS framework, but allowing for flexible, site-specific implementation based on detailed gap analyses conducted at each plant. They also invested significantly in a proprietary digital platform to integrate their APQP documentation, FMEA databases, SPC data collection, and corrective action tracking across all sites, providing global visibility and consistency.
Digital platform for harmonization. Makes sense. Any others?
One more mention was a supplier of automotive lighting systems who was implementing IATF 16949 while simultaneously developing production lines for brand new LED technologies. Their challenge was applying traditional quality tools like FMEA effectively to these novel processes with limited historical data. Their strategy involved developing advanced FMEA methodologies that integrated the standard FMEA approach with digital simulations and predictive modeling specific to the physics and failure modes of the new LED technology, allowing for more robust risk assessment up front.
Adapting the tools for new tech. Okay, so it seems common threads for success often involve tailored and practical training, smart leveraging of digital technology, and really focusing on embedding the quality principles and tools into the daily work, not just treating them as a separate overlay. Which brings us perfectly to the big payoff question. What are the actual tangible benefits of implementing IATF 16949 effectively? Why should a company go through all this significant effort?
The benefits are substantial and often far-reaching, touching multiple aspects of the business. Perhaps the most immediate and tangible benefit, as we discussed right at the start, is simply market access.
The ticket to play.
Exactly. In today's global automotive industry, IATF 16949 certification is often a mandatory prerequisite for doing business with the major vehicle manufacturers and many Tier 1 suppliers. Without it, you're effectively locked out of significant portions of the market. It opens doors that would otherwise be closed.
Okay, access is critical. But does it actually save you money? Does it improve the bottom line?
Absolutely. A well-implemented IATF 16949 system consistently leads to significant cost reduction. This comes primarily from reducing the various components of the cost of poor quality, COPQ.
COPQ. Break that down.
COPQ includes internal failure costs, like scrap materials, rework labor, reinspection time, production line stoppages caused by quality issues, external failure costs, handling customer complaints, processing warranty claims, managing product recalls, liability costs, lost reputation, and appraisal costs, the cost of inspection and testing needed to sort good from bad. By focusing on prevention and process control, IATF 16949 systematically reduces all these costs.
And are these savings significant?
The source suggests they can be very significant. It mentions studies and common industry experience showing that the cost savings achieved through COPQ reduction often recoup the initial investment in implementing the system within just 1 to 2 years. And the ongoing ROI can escalate significantly over several years as the system matures and continuous improvement kicks in. Figures like a 15% ROI in the first year, 65% after 3 years, and even 180% after 5 years are mentioned as possibilities based on source data.
Those are potentially very compelling numbers for management. What about efficiency gains? Does it make operations run smoother?
Yes, it definitely drives operational efficiency. The emphasis on the process approach leads to better definition, standardization, and understanding of how work gets done. This, combined with the focus on minimizing variation and waste, linking to lean principles, naturally leads to smoother workflows, better resource utilization, and reduced non-value-added activities. Organizations often report measurable improvements in metrics like overall equipment effectiveness, OEE, reduced manufacturing cycle times, and improved overall productivity after implementing IATF 16949 effectively.
So less waste, faster throughput. What about relationships with customers?
It significantly strengthens customer relations. By systematically focusing on understanding and meeting all customer requirements, including those tricky CSRs, and by improving quality and delivery performance, you inevitably increase customer satisfaction and confidence. Demonstrating commitment through IATF certification itself builds trust.
How does that translate practically?
It can lead to better scores on customer supplier evaluations or scorecards, which often directly influence decisions about awarding starting new business. It can help you achieve preferred supplier status, potentially giving you access to new projects earlier in the design cycle. It fosters a more collaborative, less adversarial relationship built on proven capability and reliability.
Better partnerships. And what about risk management? That seems woven throughout the standard. Is that a key benefit too?
Improved risk management is definitely a major benefit. The requirement for systematic risk analysis and mitigation using tools like FMEA proactively, developing robust contingency plans for disruptions, having effective problem-solving processes significantly reduces the likelihood and potential impact of unexpected events or failures. This leads to fewer crises, better business continuity, and increased organizational resilience, which is incredibly valuable in today's volatile global market.
Reduces firefighting. Now, a common concern sometimes raised about standards is whether having such a structured, rigorous system might actually stifle innovation and creativity. Does IATF 16949 get in the way of developing new things?
That's a misconception, actually. Implemented correctly, IATF 16949 can actually facilitate innovation rather than hindering it.
How so?
It provides a structured, controlled framework for managing the process of developing and validating new products, materials, and manufacturing processes. By requiring rigorous risk assessment, like DFMEA and PFMEA, and thorough verification and validation before full implementation, it actually reduces the risk of failure when introducing new technologies or innovations. You launch with higher confidence. Furthermore, the standard's strong emphasis on continuous improvement encourages teams to constantly look for innovative solutions to improve existing processes and products, fostering a culture where controlled innovation is encouraged. Some studies suggest certified organizations actually implement innovations more successfully.
So it provides guardrails for innovation, not roadblocks.
Exactly. It channels innovation effectively. And how does it help companies work better with others in the long automotive supply chain? It leads to better integration in the value chain. Having a common quality language, IATF 16949, and standardized methodologies, the core tools, used across the industry makes communication and collaboration between customers and suppliers much easier and more efficient. Everyone understands the expectations and speaks the same quality dialect, so to speak.
Reduces misunderstandings.
Yes. This can lead to benefits like earlier supplier involvement in customer design projects, which often leads to better, more manufacturable designs, the development of more strategic, long-term partnerships based on trust and shared understanding, and even opportunities for co-innovation between tiers in the supply chain.
Okay, so if implemented correctly and embraced culturally, IATF 16949 moves beyond being just a compliance burden and becomes a genuine strategic tool for improving almost every aspect of the business market: access, cost, efficiency, customer trust, risk reduction, innovation, and collaboration.
Absolutely. That's the potential value proposition. And it's possible, as the source suggests, to actually measure that value. By quantifying the costs and benefits perhaps through a formal cost of poor quality analysis, tracking internal-external failures, appraisal, and prevention costs, alongside implementation maintenance costs, organizations can demonstrate the tangible ROI of their quality system investment to stakeholders. Tracking key performance indicators over time and benchmarking against industry peers also helps show the value.
Measure it to manage it and prove its worth. Now, looking ahead, the automotive world is undergoing probably the biggest transformation in its history right now: electrification, autonomous driving, connectivity, software becoming dominant. How will a standard like IATF 16949 need to evolve to keep pace with these massive changes? What does the future hold?
That's the critical question, isn't it? The standard is definitely a living document managed by the IATF, and it will need to adapt to these transformative trends to remain relevant and effective. Several key areas are likely to see evolution. Well, take electric mobility. The shift to EVs introduces a whole new set of components: battery packs, electric motors, power electronics, sophisticated thermal management systems. This requires addressing new quality considerations specific to these components, like electrical safety standards, high voltage, specific durability and reliability testing for battery cycles, managing battery degradation, and controlling the unique manufacturing processes involved. Future revisions will need to incorporate or reference specific requirements for these EV components.
Okay, specific needs for EV parts. What about the explosion of software in cars?
The increasing complexity and criticality of software and connectivity is a huge driver of change. As cars become more like sophisticated computers on wheels, managing software quality, ensuring functional safety, often governed by standards like ISO 26262, and protecting against cybersecurity threats, addressed by standards like ISO 24434, become paramount quality
How
considerations.
will IATF likely address that?
Future revisions of IATF 16949 will almost certainly need to integrate requirements related to software development lifecycle management, software testing and validation processes, configuration management for software versions, and managing cybersecurity risks much more explicitly within the overall quality management system framework. It can't remain just hardware focused.
Makes sense. Cars are becoming software platforms.
Right.
What about the broader trend of digitalization in manufacturing itself, Industry 4.0?
Digitalization and Industry 4.0 technologies, things like the Internet of Things, IoT, connecting machines, big data analytics, artificial intelligence, AI, and machine learning, digital twins offer immense opportunities for quality management. Think real-time process monitoring and adjustment, predictive quality analytics anticipating problems before they occur, advanced traceability using sensors, and automated visual inspection using AI.
So opportunities, but also challenges for the standard.
Yes. Future requirements might need to address how organizations effectively integrate these digital technologies into their quality processes, how they validate the reliability of AI algorithms used for quality decisions, ensure data security and integrity, and develop the necessary digital skills within their workforce. Quality 4.0 is definitely on the horizon.
Okay. What about societal trends? Sustainability.
Sustainability and social responsibility are gaining increasing importance, not just ethically, but as business imperatives driven by consumers, investors, and regulators. We already saw IATF 16949 includes basic CSR elements, but future revisions may well strengthen requirements related to environmental impact, like carbon footprint tracking, circular economy principles, ethical sourcing of materials, conflict minerals, human rights in the supply chain, and broader corporate governance aspects. The supply chain is under increasing scrutiny.
The definition of quality continues to expand.
It does. There's also likely to be a continued drive for greater standard integration. As we see more standards emerging around functional safety, cybersecurity, environmental management, etc., future versions of IATF 16949 might evolve to facilitate even smoother integration with these other relevant standards, perhaps adopting more common structures or terminology, creating more unified management framework for automotive suppliers.
Less siloed systems.
That's the aim. We might also see shifts in quality methodologies. While the core tools remain fundamental, there might be incorporation of more concepts from Quality 4.0, digital integration, or perhaps agile methodologies, particularly in software-related areas, finding ways to balance the need for traditional automotive rigor with the faster development cycles and adaptability required for complex, evolving systems. Risk management approaches might also become more sophisticated.
Adapting the toolbox. What about global consistency?
Global harmonization will likely remain a key driver. The IATF will probably continue efforts to reduce variations in interpretation and application of the standard worldwide, potentially even pushing for more harmonization in those customer-specific requirements over time, although that's a complex challenge.
And dealing with disruptions, like the recent pandemic or semiconductor shortages.
Recent global disruptions have certainly highlighted the critical importance of resilience. Expect future revisions to likely strengthen requirements related to business continuity planning, supply chain risk management, beyond just Tier 1, flexibility in manufacturing, and the ability to respond rapidly and effectively to unexpected disruptions. Those contingency planning requirements might become even more demanding.
Building more robust systems.
Exactly. And finally, all these changes point towards the need for new future competencies for quality professionals and the wider workforce. Skills in areas like data analytics, software quality assurance, cybersecurity principles, complex systems thinking, and managing integrated management systems will become increasingly vital. Future iterations of the standard may place more emphasis on identifying, developing, and verifying these evolving competencies within the organization.
So IATF 16949 isn't a static monument, it's a dynamic standard, constantly needing to adapt to keep pace with a rapidly transforming industry. It's fascinating to think about where it might go next. Okay, let's try to pull all these threads together. Now, we've covered a huge amount of ground. If you had to boil it down, what are the absolute key takeaways you want listeners to remember from this deep dive into IATF 16949?
Okay, pulling it all together. I think there are maybe 5 core takeaways. First, remember that integration is key. Real success with IATF 16949 isn't about implementing isolated tools or procedures. It's about integrating the core tools effectively into your product development and manufacturing processes. It's about integrating your quality management system smoothly with other management systems like environmental or safety. It's about embedding quality thinking and responsibility into everyone's daily work, from the shop floor to the executive suite. And it's about integrating collaboratively with your entire supply chain.
Integration, not isolation.
Yeah.
Got it. What's number 2?
Second, recognize the profound strategic value of IATF 16949. Don't view it solely as a compliance burden or a cost center. When implemented effectively, it is a powerful business driver that provides access to markets, significantly reduces costs, boosts operational efficiency, facilitates controlled innovation, manages critical risks, and strengthens customer relationships. Frame it as a strategic investment, not just an expense.
It's a business tool, not just a certificate. Okay,
Third, fully appreciate the role of digital technology. While not explicitly mandating specific technologies yet, digital tools for document management, data collection, SPC, analysis, MSA, capability, workflow automation, corrective actions, APQP, and communication are becoming increasingly powerful enablers for implementing and continuously improving quality management systems more effectively and efficiently. Technology can help move from reactive to predictive quality.
Embrace the digital enablers. 4th point.
Fourth, understand that the effective scope of quality in automotive is broadening beyond the standard's traditional focus. Critical aspects like environmental sustainability, corporate social responsibility, ethical conduct, and overall organizational resilience are becoming integral parts of what it means to be a high-quality, preferred supplier in the modern automotive ecosystem. These factors are increasingly influencing sourcing decisions.
Quality is becoming more holistic. And the final takeaway.
And finally, perhaps most importantly, remember that success ultimately depends on developing the right competence and culture. No matter how good your documented system is, it won't be effective without skilled, knowledgeable people who understand why quality matters and how their role contributes. Fostering a genuine quality-oriented mindset and culture of continuous improvement throughout the entire organization is absolutely paramount for sustained success with IATF 16949. People make the system work.
Integration, strategic value, digital role, beyond the standard, and competence and culture. Those are great summaries. And if someone listening needs to actually implement this standard in their organization or just wants to learn more in depth after this conversation, where should they turn? Are resources available?
Oh, absolutely. Fortunately, for a standard this critical, there are many resources available to support implementation and ongoing learning. This includes, first and foremost, the official IATF 16949 standard document itself, and the companion rules for achieving and maintaining IATF recognition, which govern the certification process. These are essential reading.
The official sources.
Yes. Then there are detailed technical reference manuals published by organizations like AIAG in North America and VDA in Germany that provide in-depth guidance on how to effectively implement the core tools: APQP, FMEA, SPC, MSA, PPPP. There are numerous specialized software solutions available commercially to help manage documentation, core tool application, audits, and corrective actions. Extensive training programs are offered by many providers, covering everything from awareness level to expert and auditor certifications for IATF 16949 and the core tools. Experienced consultants specializing in automotive quality can provide guidance tailored to specific organizational needs. You can also find templates for common documents and participate in industry forums or networks for sharing knowledge and benchmarking best practices. For deep expertise, the source even mentions structured learning pathways like dedicated master programs focused on automotive quality management.
So plenty of help out there if you need it.
Definitely no need to reinvent the wheel. The support infrastructure is well developed.
Well, this has been a truly deep dive into what feels like the foundational bedrock of the modern automotive industry. IATF 16949, as we've heard, is this vital, often invisible backbone that makes the incredible complexity and global scale of vehicle manufacturing possible, striving to ensure safety, reliability, and consistency across a vast supply chain. Understanding it, as you've made clear, is absolutely crucial for anyone working in or supplying to this industry. It enables market access, drives efficiency, helps manage significant risks, and ultimately contributes to the quality of the vehicles we all rely on.
It really is a system that impacts almost everything, from the design of the smallest fastener right through to the overall performance and trust you have in your vehicle. Every single time you get behind the wheel, its influence is pervasive.
Absolutely. And just to wrap up, here's a thought perhaps to leave you, our listeners, with, building on that discussion about the future trends. As vehicles become increasingly defined by software, complex electronics, and new energy sources, and as global supply chains continue to face unprecedented volatility and geopolitical pressures, how exactly must the fundamental principles and practices embedded within IATF 16949 adapt, flex, and evolve to guarantee that same high level of safety, reliability, quality, and customer trust in the radically different car of tomorrow that we've come to expect today?
That's the multi-billion-dollar question the entire industry is grappling with right now. It's a challenge that will keep driving innovation and quality management for years to come.
Indeed it will. Thank you so much for joining us today for this comprehensive deep dive into IATF 16949. We sincerely hope this conversation has provided you with a strong, clear understanding of this essential, complex, but ultimately vital standard. If your own professional journey involves implementing or working within this framework, know that the resources and knowledge are out there to guide you.
Indeed. The journey towards quality excellence is always one of continuous learning and adaptation. Thanks for the engaging discussion.
Thank you. And thanks to all of you for listening. Until next time on The Deep Dive.